Welcome. Welcome to Presto. You got it, where we use insightful comments and analysis to make your learning easy, interesting, and fun. In addition, on academyforadvancedstudy.com, at very affordable price, we offer many tutoring programs to help you. We cover SAT, ACT, AP, all the college prep materials. We also cover K-12 subjects. We even cover college level materials. Again, at very affordable price. We offer tutoring program for advanced topics in statistics, computer science, and data science. We also cover programming and engineering, Python, Java, JavaScript, HTML, CSS, everything you need to know in the age of AI. If you want to go to medical school, we can help you too. Again, at a very affordable price. We offer tutoring programs for MCAT. Now let's go back to our talk today. What we're going to have is the second talk in the topic of alpha in Python Seaborn library, specifically when we use scatter KWS, we can specify the alpha value. So what's alpha? It sounds mysterious. It's actually quite interesting. So sometimes being mysterious is very interesting. So we already covered the code section in which alpha is used. So this is a code section we covered in our last talk in preparation for our talk today. As you can see here, we have inside this reg plot function, we have scatter KWS dictionary to specify what we want Seaborn do with respect to our data points. That's a scatter KWS means, scatter being a scatter plot of the data points. So for our purpose today, the key piece here is alpha 0.6. In matplotlib and the Seaborn, which builds on it, alpha controls transparency or opacity, if you like fancy words with fewer syllables. Opacity. What does it accepts values between 0 and 1. So remember, only numbers values between 0 and 1. Alpha equals 1.0, fully opaque, solid, no transparency at all. And alpha equals 0, fully transparent, invisible. You don't want that. And alpha equals 0.6, 60% visible, 40% transparent. Usually people will say this is a good balance, a sweet point for which you want to view data pattern for large number of data points. Why is this useful in scatter plots? If you have many data points, some of these data points will overlap, plot on top of each other. If all points are fully opaque, alpha equals 1, they overlap. And this overlap makes them look like a solid blob, so it's not going to help you that much. But this is only happen when you have a large amount of data points, but in practice, that's what you are going to have to deal with, a large amount of data points. By reducing opacity, for example, alpha equals 0.6, overlapping areas look darker, and which visually encodes density. So what it means here is more overlapping will give you a darker color. And the regions with more overlap appear darker, and the regions with fewer points appear lighter. So it gives you more control with respect to how data points are presented. This makes patterns in the data clear. That's all about in statistics, right? In statistics, it's all about the patterns. Example illustration. Conceptually, we're going to give you some guideline. So alpha equals 1.0, you see a thick dark cluster where points overlap can tell density. You sometimes if you don't have a lot of points, it's okay, but when you have a lot, this is actually quite a big issue for you. And alpha equals 0.3 overlaps gradually darken, giving a heat map like effect. Alpha equals 0.6, which is what we use. Balance. Individual points are visible, but overlap is also shown. So next, we're going to produce a few demo plots. So we have it ready for you. Actually, let's take a look at this first. So you see here we have same set of data, but we use different alpha value to plot the data. So the left we have alpha equals 1.0. In the middle we have alpha value 0.6, and on the right we have alpha value 0.3. So for alpha equals 1.0, all points are fully opaque, making overlap form a dark blob. So this is not a huge deal here because we don't have a lot of data points. But when you have a lot of data points, that become an issue. Middle one, alpha equals 0.6. It's good, so it's sitting in the middle. A balance between visibility and overlap detection. Alpha equals 0.3. It's more transparency, perhaps too much transparency, and overlap highlight density like heat map. So we have more examples. So here we are using actually. So here we have again have 3 figures, and the left also alpha equals 1.0, fully opaque overlap creates a dark blob, and the middle alpha equals 0.6. What's the difference? Difference here is that we have we use a different representation for the data points. Instead of a solid circle, we have X here. So sometimes it actually a better way to present data. So on the right we have alpha equals 0.3, and more transparent overlap gives a heat map effect. That's on the right, 0.3. The focus here is what's in the middle, 0.6 alpha. These overlaps are visible, but not overwhelming. So this is the effect of X instead of a solid data points. I think we have more here. Oh, okay. Yeah, we do. So here we have actually a plot with regression line with confidence interval shading, so you can tell the effect when you have both the data points and the confidence interval shading, and also of course regression line. So just to give you some convenient example, so you don't have to do all the hard work and produce a figure yourself. So to summarize, I think it's this one here. To summarize, we alpha equals 0.6 is probably the best point of balance. So individual points are visible, but overlap is also shown. That's all we have for you today. And remember, on academyforadvancedstudy.com and academyforadvancedstudy@gmail.com, we offer tutoring programs at a very affordable price. That's all. Thank you, and have a great day.